Ariel, listen to me. The human world, it's a mess. Life under the sea is better than anything they got up there. The seaweed is always greener in somebody else.
We've been studying about tropical ecosystems, and here is just one little tiny example of a piece of coral. And you can see that all those little individual holes is where a coral polyp would live. And remember, those coral polyps are like little tiny sea anemones that make up this piece of coral, and they live inside that coral and build that coral. And inside the polyps live a algae that lives inside them called zooxanthellae. And that's what we're going to be focusing on today is tropical ecosystems. And all over the world there's a problem called ocean acidification that we are going to be talking about today and completing a lab on. Now, ocean acidification is a term that is used to describe the ongoing increase in pH and carbonate ions in the world's oceans. Now, what we're going to start with is what exactly does that mean? So before we can even start, we need to first figure out what even is pH. Now, pH is the measure of acidity, of how acidic something is or how basic something is. Now, an acid is going to be something that has hydrogen ions. Now, those hydrogen ions are going to be something that dissociates in water. So let's take pretty known acid. We should all remember this from our first week in ocean chemistry. Hydrogen chloride. Now, when you mix this with water, you're going to get hydrogen ions and chloride floating around in the water. So with your increase in your hydrogen ions, it's going to make your water more acidic, and that means your pH is going to be low. Let's move on to our base. We'll take a pretty well-known base, sodium hydroxide, and we put that in water. What's going to happen is we're going to get an OH, and that's going to be a characteristic of bases. So with a base, you're going to have a higher pH, and your acid is going to have a low pH. Alright, so one way we can measure pH is by an indicator, and that's what we're going to be doing is using a red cabbage indicator to test different household objects like lemon juice, soaps, cleaning solutions, things like that. And based upon our cabbage indicator, which is shown, there's pH at different levels. So depending on what color it turns will depend on the pH of that solution. Here is a picture of how ocean acidification occurs. You can see that the CO2 from the atmosphere is going into the ocean water, and as the CO2 and water are mixing, those hydrogen ions dissociate in the water, which decreases the pH level but increases the amount of hydrogen ions, so it makes the pH lower and therefore more acidic. So one example of the species that is being affected by this is coral. And here's a picture of coral bleaching happening. Those zooxanthellae get too warm and they don't have enough nutrients, so they leave. And then here's a picture of where ocean acidification has been known to occur.
Is a little hermit crab with a big problem. Ocean acidification is threatening Hermes' home. 1/3 of the carbon dioxide pollution created by humans on the land is ending up in the ocean, making it more acidic and making shells and corals weak and brittle. Hermes is about to find out what a more acidic ocean will mean for him.
Alright, we're going to go ahead and split up into our lab groups. This worksheet I'm going to hand out is going to be due at the end of class, and at the end of the week your lab write-ups and your journal observations will be due.